Hi, I'm Derrick, Professor of Plant Science at Lincoln University, and we're here in one of our research fields at the horticultural research area, but it's not actually doing horticulture at the moment. It's got a lucerne experiment in it that one of my colleagues, Dr. Alistair Black, is running. It's the middle of winter, so it's 3rd of August, and it's a fairly cold day. We've had a bit of rain, and we're worried about how much moisture we might actually have in the soil coming into the spring. So one of the things we have to be concerned about with a lucerne grazing system is how much water is available to the plants as we come into the spring. Now, how much water we have will depend on how much water the soil can hold, and then how much rainfall we've had during the winter, or the period when we've had low growth and there hasn't been a lot of transpiration of the water up into the atmosphere. At the moment, through June and July, the lucerne gets fairly dormant, and any rain that falls during that period actually goes into the soil, infiltrates down into the soil, and fills that bucket of soil so that we've got a bucket of water available to the lucerne in the spring. And we measure that using a neutron probe. And the probe actually comes out in the field and it goes into this tube. And the tube has been dug into the ground, and this one has gone down 2.5 meters. And so we then put the neutron probe in and we measure how much moisture there is all the way from the top here at the soil surface down to the 2.5 meters. And from that we can see whether the moisture that we've had during the winter has penetrated all the way down to fill up this bucket. We're on a Templeton silt loam soil here, and it has the ability to hold about 550 millimeters of moisture. So we need that much moisture in the profile to start the spring season to maximize the yield potential of lucerne. If we have irrigation, of course, we can add the irrigation water on top of that. But in this experiment, in many of the areas we use lucerne in New Zealand, there is no irrigation. So we're reliant on how much winter rainfall and winter recharge we get. If we have a look at the data that we've got, it would suggest that this season we don't have very much in our bucket. There hasn't been a lot of soil moisture recharge, and that's the same as the situation we were in about this time last year. When we think about how much moisture is being used, it's a combination of evapotranspiration. So it's evaporation from the soil surface and transpiration from the plant. If we look at a canopy of leaves here where we can still see some drill rows, about 50% or more of the area is going to be bare ground. And that means that the moisture can evaporate from the soil surface. In the summer, that will be a high proportion of the moisture that's lost from the system. At the moment, we only have evapotranspiration rates of about 0.5 millimeter per day, so we're building up soil moisture. There's not a lot of leaf ground cover, so there's not a lot of transpiration occurring, and the plants aren't actively growing. This lucerne stand is in a dormant state, but it will cover the ground, and then all of the moisture coming out of the soil will be through transpiration as we go into the spring. So the combination of moisture loss from soil evaporation and transpiration through the plants is what will decrease the amount of moisture that's in that bucket. In this Templeton silt loam soil, the bucket's reasonably large, and we've seen that from the data that we've got over the last 3 years.